Hello and welcome to our lesson on addition and subtraction. So first and foremost, we're going to cover some properties, some vocab, some rules, and then we'll get right into the addition and subtraction. So adding 0 is one of the first properties we're going to talk about. When we add 0 to any number, it doesn't change its value, and we call that the identity. So when you do something to a number but you don't change it or you maintain its identity, that's an identity property. And so the identity property of addition says adding 0 to any number does not change its value. For instance, 10 plus 0 is still going to be 10, or negative 5 plus 0 would still be a negative 5, or an x plus 0 would still be x. So this will carry over to algebra as well. Okay. Now, mathematical inverses, another important topic that relates addition and subtraction. Inverse is a fancy word for opposite. Okay. Opposites, inverses, those are interchangeable. So another word for inverse is opposite, and addition and subtraction are inverse or opposite operations. So adding 5 to a number and then turn around and subtracting 5 from the number would get you back that same number. Okay. In fact, the addition of opposites is always going to equal 0. So for instance, the opposite of positive 5, again adding a 5, is a negative 5 or subtracting 5. And then furthermore, if you were to combine those two numbers, if you were to put together a negative 5 and a positive 5, you end up with a 0. Okay, so adding opposites, which would be positive and negative of some number, is always going to result in 0. It's like they cancel one another out. All right, so we're going to get into some of the adding and subtracting, which may have been a while since you've seen some of these rules. But addition is commutative. Remember, that property means we can change the order in which we add and still get the same answer. But unfortunately, subtraction is not. So if you have a problem that contains both operations, what we're going to do is work from left to right. So that's the rule, work from left to right when you have operations that aren't necessarily commutative. And when in the process of working left to right through the addition and subtraction. The rule is, if you are combining, and I use that word in place of addition and subtraction, so when you're putting numbers together with addition or subtraction, if the numbers have the same sign, so if you're combining a bunch of positive numbers, then you're going to add them and the result will be positive. If you're combining a bunch of negative numbers, you would still add them, but the result will be negative. So when you're combining numbers with the same sign, you're going to add and keep the sign. So I like to remember same sign sum. Okay, that's what helps me remember. And if you're going to be combining numbers with different signs, so if you're going to put together positives and negatives, if they have different signs, what you want to do is subtract the two numbers, or the three numbers, or however many numbers it is. Subtract the numbers, and then you end up keeping the sign of the larger number. So when it's the same sign, you add them, find the sum. When they're different signs, you subtract them, or you find the difference. So same sign sum, different signs, find the difference. Okay? So let me look at or show you an example here where I have every combination of a positive and negative I could think of. So a straightforward here, 8 plus 10, those are both positive numbers. When you don't see a sign in front of the number, it's implied that it's positive. So a positive 8 and a positive 10, you would add those and keep the result positive, so it's positive 18. Okay. Now here is an equivalent expression, but technically what it's asking you to do is subtract a negative. So subtraction and negative, that's like a double negative. It's like when you're speaking and you say something like, I don't not, you wouldn't say the word don't not you wouldn't put those words together in a sentence. They sort of cancel each other out. If you don't not, that means you do, right? So what we want is to make that double negative a positive. This is the simpler way to look at that, just like the simpler way to say I don't not is I do in English. So the double negative here makes a positive. So this together makes a positive. So this is the same thing as what is 8 plus 10, which means we still have 18. Okay? Now the next one, we have a negative 8 and a negative 10. Well, a negative 8 and a negative 10 is just like the positive 8 and the positive 10. Same sign, so we're going to add them. We're going to get 18, and we're going to keep the sign, so it's going to be a negative. And let me keep my colors consistent here. So we're going to add these. 8 and 10 makes 18, and we keep the sign, so negative. Okay? And then the next one right below it is exactly the same expression. Double negative makes a positive, but a positive negative, that's still going to be a negative. So this is equivalent to what's negative 8 minus 10. Or if you're adding a negative 10 to a negative 8, again, you're adding those numbers and you're keeping the sign, so you still end up with a negative 18. Okay? Next one says negative 8 plus 10, so now we're looking at different signs. That means we want to find the difference. So the difference between 8 and 10 would be 2. And what we do is we keep the sign of the bigger number. So 10 is bigger than 8, 10 is positive. That means this result is going to be a positive 2. Okay? And here again we see a double negative. Double negative is a positive. So this is the same thing we just looked at. This is a negative 8 and a positive 10. If we subtracted 8 and 10, we'd have a difference of 2. Bigger number still 10, so this answer is still positive. Now if we switch this so that we have a positive 8 and a negative 10, we would still be finding the difference. The difference, because they're different signs, right? One's positive, one's negative. The difference is still 2, but this time the bigger number, 10, is negative, so our result is negative. And again, a positive, negative here, the negative's going to supersede, and so this is the same thing as we just saw. It still says 8 minus 10. Different signs, we find the difference, which is 2. Keep the sign of that bigger number, so a negative 2. Okay? Luckily, if all the rules get a little complicated for you, you could absolutely use a calculator to verify anything that we just did there. Alright, so let's try this with a bigger problem. What I would do first, if I was looking at a bunch together, is get rid of any parentheses. So if I see any double signs, I want to simplify that. So for instance here, when I see a positive times a negative or a positive negative, that's really just the same thing as subtraction. So I'm going to rewrite this as negative 28 minus 44 plus 17 plus 31, and then minus that 94. And because we have addition and subtraction within one problem, I'm going to work from left to right. So first I would combine these two numbers. The first two numbers, so negative 28 and a negative 44, or negative 28 minus 44, you could read that either way. But those two numbers, if I'm combining them, they have the same sign, so I want to add them and keep the sign. So adding 28 and 44 is going to give me 72, and I'm going to keep the sign, so negative 72. And let me just bring the rest down. And then I'm going to go one step at a time here, so now I'm going to put the next two numbers together. So now I'm combining negative 72 and 17. Now those are different signs, so I want to find the difference. So the difference between 17 and 72 is going to be 55. So I'm going to find the difference, which is 55. And then I want to keep the sign of the bigger number. Since the bigger number between 17 and 72 is 72, I want the sign to match that 72, so it's going to be a negative 55. And then again, I'm going to bring down the 31 and minus 94. Now I'm going to go with the next two numbers, 55 and 31. One's positive, one's negative, so I'm going to find the difference. So 55 minus 31 gives me a difference of 24. And again, the bigger sign is 55 is negative, so I'm going to make that a negative 24. And then lastly, I'm going to bring down the minus 94. So when I put these two guys together, same sign, sum. So I'm adding 24 and 94. 24 and 94 is going to be 118, and I keep the sign. So add them, keep the sign, that makes my result a negative 118. All right, so that was a lot, and some of you may have been able to do that a little quicker than I could, but let's just confirm. If we put it all into the calculator as originally given, negative 28 minus 44 plus 17 plus 31, and then we're going to go plus just as they gave it to us so I can make sure I didn't screw anything up there. There it is, a negative 118. So calculator will absolutely do that work for you. Okay? Alright, so let's try that process again. This time I got some fractions in there, but we have common denominator, so we should be in good shape. So I'm going to start with the getting rid of the parentheses. Again, a positive times a negative here, or positive negative is just minus, it's subtraction. So let's rewrite this. Negative 4 over 7 minus 3 over 7 plus 1 over 7 minus 5 over 7. So one at a time now. Put these together first. Same sign, sum, keep the sign. So negative 4 and negative 3 makes negative 7 over 7. Okay? Next, bring down my 1/7 and my 5/7. And then go here. Different sign, so I would find the difference. The difference between 1 and 7 is going to be 6. We're going to keep the sign of that bigger number, so negative. So negative 6/7, and I bring down my negative 5/7, and then go one more time. When I put these two together, same sign, sum, so 5 and 6 is 11. Keep the sign, so negative. So negative 11 over 7 is our result. And again, the calculator would be happy to do this for you. So if you're going to use Desmos 4/7, we hit the divide button and it would give us the ability to put in the fraction there. Minus 3/7. And then you want to arrow out of the bottom of the fraction, so plus 1/7. And then plus, let's put in a negative 5 over 7. Now notice that Desmos gave me a decimal, but in the blue, if I hit the little picture of the fraction in the blue, I can convert between a fraction and a decimal, and there it is, negative 11/7. Okay? Alright, we got another one here. I would still start this by getting rid of the parentheses. So I have 1/6 minus 2/3. This time, a double negative makes a positive. So this is going to be a plus 1/4. Now I cannot add fractions unless we have common denominators. So I need a common denominator for 3, 6, and 4. And I don't know if I showed you this before, but you can find a common denominator in your calculator or using Desmos. If you go into functions and let's see, I think it's in miscellaneous. Yeah, the least common multiple or least common denominator, it's the same thing. So if I actually put in here, what is my least common multiple for 6, 3, and 4, it will tell me that 12 is the least common multiple, which means that is my least common denominator. So if I need a least common denominator of 12, then I'm going to have to multiply and fix all these fractions here. So I'm going to multiply this first fraction by 2 over 2 to get that 12. I'm going to multiply the second one by 4 over 4 again to get that to be 12. And I'm going to multiply this last one by 3 over 3 again to get that to be 12. So what we're looking at is 2 over 12 minus 8 over 12 and then plus 3 over 12. Okay, now it's much like the last one. We can go left to right with this. So I'm going to put these two fractions together. One's a positive, one's a negative. Different signs, find the difference. So the difference between 2 and 8 is going to be 6. And again, 12. Since the 8 was bigger, this is going to be a negative 6. Bring down my plus 3 over 12. And then put these two together. So again, different signs, I find the difference. The difference between 3 and 6 is going to be 3. Keep the sign of the bigger number. So negative 3/12. And the negative 3/12 actually reduces because, let me change colors here, because 12 on the bottom is the same thing as 3 times 4. We can reduce out the 3's. And so negative 1/4 is going to be our final reduced fraction on that one. And I'm not sure why I boxed that in and not the rest, so let me unbox that. Okay, so there it is, addition and subtraction. I think we've got some more examples on the back here, but now we're going to look at how this works with algebra. Okay, we throw some variables into our expressions. So the same rules apply, the same arithmetic rules apply. If we have different signs, we find the difference, keep the sign of the bigger number. If we have the same sign, we find the sum, we keep the sign. That's the same rule, except we can only combine, again meaning add or subtract, what we call like terms. And in order for our terms to be like terms, they have to match. So for instance, constants, any constants you have in your algebraic expressions, those are always like terms. Constants, remember, don't have any variables. So 2's and 3's and 4's and 5's, any of those numbers that don't have variables, we can always combine those. And then the variable terms that we're looking at are going to be like terms if they match. That means the variables and the exponents that are with them have to match, and I'll show you with some examples. But when we go to combine these like terms, what we're actually going to combine are the coefficients. So coefficients of like terms of the variable like terms can be combined if their variable parts match. So for example, these are all the same problem here, okay? Same exact problem. That's why I try to keep them in the same color. If we were adding 2 and 4 and 7, 2 plus 4 would be 6, 6 plus 7 is going to make 13, so we have 13 here. The next problem works exactly the same way. These are all considered like terms because the variable parts of each of the terms matches. They each have an x to the first power. So when we combine them, we combine their coefficients. So 2 and 4 is 6, and 6 and 7 again makes 13. So this time it's 13 x's that we have all together. And then the next one will work exactly the same way. These are all like terms. We combine their coefficients. 2, 4, and 7 again makes 13, but this time it's 13 y's that we have all together. And then in the next one it's 13 z squareds that we have all together. Okay, now notice I changed color here. In the next problem, the 2x and the 4x are like terms. Their variable parts match, but the y doesn't match an x. It's not the same variable. It means we can't combine it. So I can combine the 2x and the 4x by combining their coefficients. So 2 and 4 makes 6. So I have 6 x's total there, but the 7 y's could not be combined with the 6 x's. So in that answer, there are those two separate terms. And then in the third one here, x, y, z, all different terms, all different variable parts. None of those variable parts match, which means none of those terms can be combined. So 2x plus 4y plus 7z is it. You can't do anything to try to simplify that further. Okay? So let's look at this next example. These are all like terms. So all like terms, I can combine all of these terms, and I do that by combining the coefficients. So the coefficient of 3 minus 6, let's take care of these guys first. 3 minus 6, again, different signs, we find the difference. So the difference between 3 and 6 is 3. We keep the sign of the bigger number, so negative, and those are going to be x's. And then I still have this minus 4x to bring down. And now we have the same sign, so we find the sum. The sum of 3 and 4 is 7, and then we keep the sign, but they are x's here. So when we combine them, and I mean the like terms, we're combining those coefficients. We're not changing that variable part, okay? So the x, think of like x's as apples, right? You have 3 apples, you combine 4 apples, you end up with 7 apples. So the apple doesn't change, just like the x is not going to change. All right, let's got another one here. Okay, looking at number 7, I have 2 sets of like terms, so I can combine these 12 x's and these 3 x's. So when I put together the coefficients of 12 and 3, I end up with 15 of those x's all together. And then I can combine these constants. So 1 and negative 5 can go together. 1 and negative 5, those are different signs, so I find the difference, which is 4, and I keep the sign of the bigger number. 5 is bigger than 1, so that's going to be a minus 4. So 15x minus 4 is my simplified answer there. Okay, or here, I can combine an x and another x. Now, if you don't see a coefficient in front of the variable, there is an implied 1. So there's an invisible 1 hiding here and an invisible 1 hiding there. Okay, so if I have 1x and another 1x, that's going to be 2 of those x's all together. And then I can put together these like terms. They have the same variable parts. So a negative 8 and a positive 6. Difference, because they're different signs, the difference is going to be 2. And we're going to keep the sign of the bigger number. And those are y's. So negative 8y plus 6y is negative 2y. And that is as far as I can go with that. Okay. And then number 9, we're a little bit of a different concept here. What we're trying to do in this one is we have actually an equation and not just an expression. And we're trying to make this whole thing zero out. So we have 2 blanks in here because we have to add some terms in here to cancel out the 8 and to cancel out the 23. So this is back to our concept of opposites. If I have a positive 8x here, and I want to get rid of that, what would I have to add to it to make it be 0? I would have to add its opposite. So the opposite of a positive 8x is going to be a negative 8x. And the opposite of a positive 23 is going to be a negative 23. And so those opposites are going to 0 out in this equation. Okay? Now here, we've got to be a little bit trickier. Let's see what's going on either side of this equal sign. On the left here, it looks like we have 9x and 1x, which makes 10x. Well, that's what we have here, so I don't have to mess with x's. There are 10 on each side, so that's balanced. But on this side, I have a negative 7y, and on this side I have a negative 4y. So I have to put something in this blank here to make negative 7y altogether. So altogether, to make negative 7y, I would have to put a negative 3y, because negative 3 and negative 4 is the only way to get to that negative 7 total. Hopefully that makes sense. Okay, so this, maybe I should rewrite this for you. This blank, let's leave that, plus, when we put together 9x, oops, I wanted that to be red, these 9x's and that 1x, I have 10x. And then I still have a minus 4y, and then again 10x and a minus 7y. So since these parts are already good, they match. Again, we're just trying to make the y's balance out too. So the negative 3y here and the negative 4y would take us to that negative 7y total. So negative 3y was missing from that blank. All right, and I got one last problem. Finding the perimeter. It may have been a while since we've done any geometry, but technically this is a geometry-related problem, an application of addition and subtraction, or in this case, addition. To find the perimeter of any polygon, in this case we have a trapezoid, but to find the perimeter for any polygon, whether you knew this was a trapezoid or not, we're adding up the sides. So perimeter is the sum of all of the sides. The sum of the side lengths. So in this case, if it says to find the perimeter, we just have to add the 5x with the 8. I don't know what happened when I was trying to write that 8. The 9 and the 7x. So those are the 4 side lengths. I'm just trying to add those together to find my perimeter, which I'm going to call P. So my perimeter is going to equal, I'm going to combine the like terms. 5x's here and 7 more here gives me 12 of those all together. And I'm going to combine my constants, so 8 and 9 makes 17 altogether. So this perimeter is going to equal 12x plus 17. And that's that. Okay, so hopefully you have enough background here with some addition and subtraction, just our numbers and then obviously the algebraic expressions as well. So hopefully, again, you've dusted off the cobwebs, you're pretty solid with addition and subtraction. Make sure if it's algebraic, you're only adding and subtracting like terms, and when you do so, you're changing the coefficients, not the actual variable pieces. All right, you've got some practice problems to work on, but as always, if you need any extra help, just reach out. All right, until next time, take care.